In this video, we're going to be examining histograms and other graphs. We're going to start by learning what a histogram is by watching this video posted by Schmoop.
We speak student!
Histograms a la Schmoop. Our world has a lot of different kinds of grams. In the old days, we had telegrams deliver our news. Now we shoot off an Instagram. We use sonograms to see how our babies are doing, and electrocardiograms to see how our tickers are doing. And we sure wouldn't want to forget about this gram. But none of them showcase data as well as one of these bad boys. A histogram is kind of like a bar graph, without the space in between the columns. The main difference is that the bar graph works to better chart individual data, while histograms do the job if you're charting a range of info. Say you wanted to plot the times of bobsledders in the last Olympics. You'd have a lot of dots on that line if you had to plot every single time recorded by 100 different sledders. That's the beauty of a histogram. It lets you gather a group of data.
Smile.
Like all the sleds between 1 minute 30 seconds and 1 minute 32 seconds, and display them all together. A lot easier to read. Plus the data looks like a really cool skyline. Just try and have this gram do that. Yeah, we thought so.
So think back to yourself for just a moment. What is one fact that you just learned in that video? Some of the important things in that video were that we learned frequency is the number of times something occurs. Histograms show the frequency of various intervals. The bars will touch in a histogram, but they do not touch in a bar graph. Histograms display quantities and ranges, and bar graphs show categorical data. So ask yourself this question and pause the video if you'd like to examine it a little bit further. But is this a bar graph or a histogram? What about this one? Is it a bar graph or a histogram? The first graph was a histogram. It showed numerical data in ranges, and the bars were touching because the ranges of numbers are consecutive. So by that we mean in this histogram, it was discussing the grade distribution for the number of students and what grades they received. So there were students that received between a 0 and a 9. They received 10 to 19, 20 to 29, etc., all the way up to 100%. But because these ranges are back to one another, because if you get 9%, that's right before you could get 10%, so they are those intervals that are consecutive to one another, these bars are going to be touching. So it's a histogram, and it's showing us that there were about 8 or 9 students that were in this first bar. Then from 10 to 19, that bar went up to the number 10, so there was 10 students that scored between 10 and 19. You can see that the highest range of grades here was between 50 and 59. That was the average number of scores, or the highest number of scores there. So there was over 50 students that scored in that range. Now our bar graph was slightly different because this was talking about the type of pet that you own, and so it was broken down by pet on the x-axis versus having numbers there like we did in our histogram. You can also see that the bars here are not touching, and that's because if you have a rabbit, it has nothing to do with you having a dog or not having a dog. So they don't have to do with one another, so they're separated here. And we can see that rabbits had 4 people with a rabbit, there were 8 people with a dog, and the most popular pet here was a cat with 10 people. So the data here in the bar graph is shown in categories and not numbers, and the bars do not touch because the categories are not consecutive or related. This is an example of a histogram. Pause the video and think about one feature of the graph that you recognize from other graphs you might have seen in the past. These are the parts of a histogram. We have the title, in this case, the height of apple trees. We have an x-axis label, which is labeling the height by intervals. So from 0 to 4 feet, 5 to 9 feet, 10 to 14 feet, 15 to 19 feet, and 20 to 24 feet. On our y-axis label, it says the number of apple trees, and that's telling us the number of times something occurred, or the number of occurrences. So we were drawing those intervals by groups of 5. So then to read this, we want to look at the bars. So between 0 and 4 feet tall trees, this bar goes a little bit above the line for 5. That means we can assume there are 6 apple trees in this category. Then from 5 to 9, that bar goes up to the line for 10, which means there are 10 trees that were between 5 and 9 feet tall. We can see that the highest bar in our histogram here was between 10 and 14 feet tall, so there were 25 trees there. So we can assume that the trees that would that if we grew an apple tree, we would expect that our tree is probably going to be somewhere between 10 and 14 feet tall because that was the highest number of occurrences between all of the heights that we had here. The next interval showed us that there were about 9 trees that were between 15 and 19 feet tall, and finally between 20 and 24 feet tall, there was only 2 trees that got to be that tall. So that's how you can find the parts of the histogram, what they mean, and how to read this. So now that you've learned that, I want you to pause the video and think about how many apple trees are between 15 and 19 feet tall. The answer to that question is that there are 9 trees between 15 and 19 feet tall. We look at the range from 15 to 19 here, and the bar height is just below that line for 10, so we can say that that's 9 trees. How many apple trees are less than 10 feet tall? To answer that question, we want to look at the ranges that are smaller than 10, so between 0 and 4 and 5 to 9. We only include these 2 bars because our next range is 10 to 14, but a tree that is in that range would not be under 10 feet, it would be 10 or more. So we only focus on these first 2 bars. The first bar was a little bit above 5, so we can say that there were 6 trees between 0 and 4 feet tall, and then there are 10 trees that are between 5 and 9 feet tall. So that means there is a total of 6 plus 10. There were 16 total trees that were less than 10 feet tall. How many apple trees are greater than 14 feet tall? So again, we need to focus on 2 groups here, 2 bars. There were a total of 11 trees greater than 14 feet tall, and we only want to look at the bars that were from 15 to 19 and 20 to 24. We don't want to look at the middle bar because 14 would not be greater than 14. We only want the ones that are larger. So the 15 to 19 bar had 9, the 20 to 24 had 2. 9 plus 2 gets us that total of 11 trees that are greater than 14 feet tall. This is an example of a line plot, and then to read this, I want you to answer the question, how many of the items sold on this line plot cost between $0 and $2? So hopefully you were able to pause and count. On this line plot, there are 15 items that cost between $0 and $2. We read this by looking at the horizontal axis down here, where it's labeling the price of items, and it tells us that each X represents 1 item. So when it asked us to look for the cost between $0 and $2, well, there's no items that are $0, so we look at $1 items. That would be between $0 and $2. And if you count the X's above the 1, there are 10 items that were each $1. Then there were 5 items, or 5 X's, above the $2 item cost. So our total amount of items that were between $0 and $2 were 10 plus 5, which is a total of 15. So now comparing that same line plot we were just looking at, do you think that it's representing what is shown in this histogram? Are they showing the same data? So pause the video and try to think of how you could answer this question. So the answer to my last question is yes, this histogram does show the same data as the line plot. It can be seen by comparing the height of the bars in the histogram to the number of X's in each range on the line plot. Use the colors to help compare the groups. So up here we have our line plot, and I've highlighted the ranges that were listed in our histogram down below. So the first bar in our histogram was showing a price range of items between $0 and $2. Our bar looks like it was somewhere between 12 and 18. So when we go up to our line plot now, we can specifically see how many that was. We only focus on the items that are between $0 and $2. So again, we would count the number of X's in this blue shaded box, and there are a total of 15 items. Well, 15 is right in between 12 and 18, so that bar looks like it's the right height so far. Then we check our next range of items, which was $3 to $5 items, and that would be this column right here. So we have 6 items that are above the 3. We have 0 items above $4 and 0 items above $5. So the total number of items in this pink category was only 6, and it looks like that bar is lined up with 6 on our histogram. So the pink category matches. We verify for the green category from $6 to $8 items. So above 6, there were 6 items, above 7, there were 0, and above 8, there were 0. So our total number of items there was 6 X's, or 6 items, and so that does match our line, or the bar on our histogram for the green section. And then we just double check that our last bar matches because so far everything looks good. Our final bar says $9 to $11 items. On our line plot, if you count all of the X's here, above $9 it was 8 items, above $10 it was 0 items, and above $11 it was 9 items. So we had 8 plus 9 for a total of 17. And you can see that the bar that is yellow on our histogram is right below that line for 18 on our y-axis, so it does get to about 17. So that is the proof there that our histogram does match our line plot. So go ahead and pause the video and think about one observation you notice about this pie chart. Now, considering that same pie chart, does it match the histogram shown below? Pause the video and think about what your answer would be here. So to answer our last question, yes, the pie chart does match the histogram. We can tell by comparing the size of the sections and the height of the bars. So we look at the sections in the pie chart and see if those sizes match the height of the bars in the histogram. We can use these colors that I have here to help us compare. So looking first at the one that kind of stands out to me, the largest section here was the 0 to 14 items, and that was our purple section in our pie chart. So it's the largest one, so in our histogram it should be the tallest bar. And if you compare this bar from 0 to 14 with the rest of them, it is the tallest in our histogram, just like it was the largest section in our pie chart. The other thing that stands out to me is the smallest section. So it's kind of like when we found the largest, now we can find the smallest. That was items that were between, or the number of items between 45 and 59, this green color here. And that should be the smallest section in our chart, which would correlate to the smallest section on our histogram. So you can see that those two greenish bars there are both the smallest in their graphs. Then the other thing that kind of pops out is the pink and yellow sections are the same exact size on the pie chart, which would tell us that on our histogram, those should be the same height of bars. So between 15 and 29 and 30 to 44, those bars in the histogram are the same exact height, just as they were the same size in the pie chart. That leaves us with this blue section that we haven't really discussed yet. It is a little bit smaller than the purple chart, or the purple section, but it's bigger than the rest of the 3 sections, the pink, the yellow, and the green. So it should just be a little bit shorter than the purple, which we can see it is, but it's also still larger than the other 3, which it is. So that's why this pie chart and this histogram do end up matching each other. Now finally, for our last type of graph, we are going to compare this stem and leaf plot to this histogram. So pause the video and think to yourself, do you think this stem and leaf plot will match the histogram? To answer our question, yes, the stem and leaf plot matches the data in this histogram. The numbers that are listed in the stem and leaf plot can be put in ranges that match the height of the bars in the histogram, and we'll use the colors to compare again. So in the stem and leaf plot, something to remember first before we start comparing the data is you have to know how to read a stem and leaf plot. So the stem is going to be the first number that you write, and the leaf is the second number. So for example, in the key, we had a stem of 2 and a leaf of 2, which is rewritten as the number 22. So that means to write out all of these numbers in a list, which I think is helpful when you're dealing with stem and leaf plots. My first stem is 0 and my first leaf is 4, so I would write that as 0, 4. But we say that that's just the number 4. So that would be the first number in my list here. My next stem is 0 and my next leaf is 4. So again, 0, 4 becomes 4. Stem of 0, leaf of 5 becomes 0, 5, or just written as 5. Then we have our next row where the stem is 1 and the first leaf is 0. So we write that as 1, 0, or 10. Then I have a stem of 1 and a leaf of 2, so we write it as 1, 2, or just 12. So you continue this process to get all of the numbers listed, and as you can see, I wrote them down in the bottom right corner of our slide. Then what I did was I highlighted each of the ranges of numbers based on how the histogram had grouped them. So the first bar in our histogram had an interval of 0 to 14. So I looked there, and then I compared that to the list of numbers that I found in my stem and leaf plot, and there was 4, 4, 5, 10, 12, and 12. That was 6 numbers that were between 0 and 14 in my stem and leaf plot data, and that corresponds to the 6 that is the height on my histogram. Then we can do the same thing for our pink section, so between 15 and 29. I highlighted all of the numbers that would be between 15 and 29 in pink, and that was 15, 15, 17, 22, 22, and 28. That was 6 different numbers, and this histogram bar was again 6 above that category. So it matches for our green category of 30 to 44. We had 36, 42, and 44. It matched our yellow category, which was between 45 and 59. So 45 and 55 were right there. There's 2 numbers. And then our red category was 60 to 74, where we had 68, 68, and 69. That was 3 different numbers in that category. So as you can see, the stem and leaf plot is definitely a lot more specific on what the actual numbers are that we're dealing with. The histogram kind of just shows you that overview of the range of data that is available based on the data shown in the stem and leaf plot.